Hello everyone. In today's video, we will be reviewing your worksheets from throughout the week. So let's see if you did them correctly. I'm going to start with symmetry because that's the easiest one. Let's just get that through. Okay, so uh, here we need to color the shapes, the images basically that are symmetrical. I'm actually just going to make the lines of symmetry. So here, this one has a line of symmetry right here. You can see that if I folded the shape one half onto the other, they would fall exactly on each other like mirror images. This one is not symmetrical. Neither is this or this, but this seems symmetrical almost, but it depends really on how strict we are being. So if we're being extremely strict, and you can see that the smile here is a little off, and the legs shouldn't be facing this way. Here, the legs should not be facing this way. If we want to be very strict, then we would not consider this a line of symmetry. So it depends on how strict we want to be. Okay, now we need to draw the lines of symmetry for these shapes. So with the star, I even showed you that in the video. So we see that the lines of symmetry are exactly from the point to the other side. Didn't do that one correctly. Let's redo that one. So from here to here-ish, there we go. And then from here to here. And let's not forget the last one. Here to here. And there are all the lines of symmetry for the star. Next up, we have the rectangle. The rectangle can be cut here and here. Oh, it should be about halfway through. Yeah, looks about right. I cannot cut it here or the other way here, because if we folded them, if we folded this side onto this side, they would not fall exactly onto each other. You can test that by taking a piece of paper and trying to fold it on the line that unites the opposite corners, basically. Next up, we have a heart, and the heart only has one line of symmetry. Here we have a hexagon. So this hexagon can be separated like this, here, and here. And then it depends, basically, because it looks like this hexagon is a little stretched. So because just turn your head a little bit to the side. If it were not a little bit stretched out, then if you were to turn your head to the side, the shapes should look exactly the same. But let me show you what I mean, actually. I'm actually going to take this shape and I'm going to turn it a little bit. I'm going to turn it so that this side is facing down, right? Now, do you see how this shape now, it looks like almost like it's leaning towards the left a little bit? Right, let's take all this away. So now that you look at it, do you see that the shape is a little bit like it's leaning a little bit to the left? Like if this was a house of cards, it would almost be ready to topple to the left. That's because the sides are not equal. The sides of the hexagon are not equal. These two sides here are a little longer than the rest, which means that I cannot, in fact, separate the hexagon, find more lines of symmetry than the ones that I originally drew. So these are the only two lines of symmetry actually for the hexagon. If they were equal, if the sides were equal, then I would be able to separate it in more ways. I would be able to separate it here and here. Well, not exactly like that, but I would be able to separate the entire shape on each of these lines. And even here, I could separate it on the angles as well. So here and here, it could have a lot of lines of symmetry if the sides were the same, but as we proved, they're not. So the only two lines of symmetry are the ones that you can see right now. Next up, we have a trapezoid right here, and I need to draw a line right down the middle, so right there. That's the only line of symmetry. Anything else, and it will not fall. One half will not be mirrored, basically, exactly as it should be. So then, if you want to check your answers, there you go. That's all of them. I will be closing this now. Next up, we have, actually, let's continue with the symmetry. Okay, so here, it was a little drawing exercise. So we wanted to make this, we didn't need to make it exactly the same. So I'm not expecting you to be an artist or anything, but just as close as you can. So basically the whole point was that, okay, so the eye needed to be in the correct square, for example, and the nose needed to be in the correct square, and the paw should have ended up in the correct square. So for example, if you drew, the eye should have gone here, right? That's the whole point of making it symmetrical. If instead of drawing the eye here, you drew it like here or here, that was what you should not have done. So the eye should have been here, give or take. Nose should have been here. Now the ear, you can see that it reaches from the line of symmetry at the very top, one box to the left. That's where it finishes up. So we are going to need to take the ear up here. Give or take, it doesn't have to be exact again. Come back down here and then circle down, right? And there's the head. And then we want the paw. The paw starts in the first box here and ends up at the line of symmetry. So let's make that. Then we have the belly right here. Oh, come on, it's not supposed to be a straight line. And then we have the paw, right? And you can make 3 little dots. Again, it does not need to be exact. just to show that we have some idea of what needs to be going on in order for this to be symmetrical. That's all we want. And there you go, that's your symmetrical bunny. Oh, and I forgot the inside of the ear. Sorry. Next up, we have the flower. Sorry, the flower, the butterfly. Got confused there. So here, in order for this to be symmetrical, the antenna, as you can see it right here, it's going to need to go this way. First up, the eye, and then the antenna, which needs to go like, come on. Okay, I didn't say exact, but that was a bit too much. There we go. Then the body, and then see, now here comes in the symmetry. So here you need to see where the wing reaches out to. So if you made it like this, say you made it like this. Now that's too small. That's too small. You can see it. It's not a mirror image. It doesn't have to be exactly a mirror image, but the whole point is to see where the wing goes. It reaches all the way about halfway to the last box. So here we're going to need to reach about here. Okay? So we're going to start from here, and we're going to go up, and then we're going to reach about halfway. Now the dots, you can see that they're on the second to the last boxes. So they're going to need to be in here. So one is going to be here. One is going to be here. And one is going to be here. Lastly, we have the last part of the wings. And there you go. That's the end of that. Again, as you can see, they are not perfect, of course. Like here, the ear is all messed up. But the whole point was we got the dimensions correctly, at least somewhat correctly. Let's move on. Let's finish off the symmetry. Okay. Okay, so here it wants us to color the one half basically of the symmetrical shapes. So let's do that nice and quick. 1, 2, 3, 4. Next up, we want to draw the lines of symmetry for whichever of the shapes has them. So immediately here we can see a line of symmetry right here. This one doesn't, because you can see it's got the clover here for a leaf clover. We can't find any line of symmetry here. And the same goes for the fish. If I cut it here, then there's the tail on this side, head on this side. If I say here, there's one fin on top and two fins on the bottom, there's an eye on the top, no eye on the bottom, so no line of symmetry here. And then we have the bear. The bear does have a line of symmetry coming down its face, but not this way. Because there's ears and eyes on top, whereas on the bottom that would be nose, mouth, and so on. The butterfly has one line of symmetry again right here. And that's it for this exercise. I do believe that wasn't too difficult. And here again we have this where we need to fill in the missing half for each of these. So let's do that. Now here you might get a little confused in the beginning and try and do this, for example. Come on. All right. Sorry. And I'm going to make my half purple just so you can tell it apart easier. I'm going to make it like this. Well, actually, no. That's a problem. Why? Because it needs to be a mirror image. And this is not a mirror image. To be a mirror image, lines need to be facing the same way. This first line, for example, needs to be facing the same way towards the line of symmetry. So it needs to be looking towards the line of symmetry. Come on. There we go, like that. And the other two seem to be looking straight up. And then the others are looking away. So this has 3, the other one, we need another 3. Then we have a square eye. Here again, you might get confused about where to place the dot in the eye. If I place it here, that's not symmetrical. It needs to be, you can see it's towards the center of the eye. So right there. There we go. And then we have a sad face, and I made it too high. There we go. Triangle leg. And then a little arm right here. Okay. Actually, because it's a little difficult to draw right here, what we're going to do is, because I don't want to waste your time, so here's what we're going to do. We are going to do this. And now you can see perfectly what the other half should look like. And again, it doesn't need to be this perfect, but you get the idea. Let's move on. There we go. And that's that. That's all there is to it. Now you can see the completed images. I'm closing this exercise now, and we're moving on to our triangle exercises. Okay, so I'm going to do this one first. I'm going to start up here, but you need to give me a second to get my protractor. no, it does. It's going to need to be 43. 43. And the sum of the angles needs to be 180. In the other shapes, so in rectangles and trapezoids, uh, the sum of all the angles needs to be 360 degrees, always. Let's take our protractor. Where is it? There we go. And you could have found the 360 by measuring all the angles. Here, we're probably gonna find 90, 90, 90, and 90. But let's measure just in case. And there we go. The first one is 90. And you can probably already see that all these angles are right angles. So yeah, if you measure the rest of them, what you're gonna get is 90. All four are 90 degrees. And together they make 360. You can also see that these two are right angles. So this is a right angle, and this is also a right angle. But let's measure the other two, since we're not 100% sure what they might be. Okay, so this is 60 degrees. So together, all the angles I have up until now are 90 and 90 makes 180 plus 60 makes 240. So this one is going to need to be 100. Wait, sorry. Did I say 60 here? No, that's my mistake. See, I get confused sometimes as well. I saw the 60 up here and I said 60, but since the side we are starting on is here, we need to go based on the inner circle. And the inner circle says 120. So here, this is actually 120. And I should have immediately noticed my mistake here because this is an obtuse angle. And it couldn't have been 60, which is an acute angle. This one is actually 60. And if I were to take my protractor and measure it, I would find 60 indeed. Now you may not have found, so here maybe you found 121, or maybe you found 119. Here maybe you found 59 or 61. If you're off by like 1 degree, that's okay. I mean, we've said this before. It could be human error. Like here, maybe I haven't placed the point that should be touching on this point right here. Maybe I haven't placed it perfectly 100%. So that's okay. Okay, so here we want to describe the triangles. We want to define the triangles based on their angles. Okay, so that's something we talked about before Easter. So let's talk about these triangles based on their angles. You can see here that all the angles are acute. So this is going to be an acute triangle, or in English, trigonio. Then we have this one right here, which you can see has one right angle right here. So this is going to be a right triangle. In Greek, orthogonio, trigono. You know what? I should have actually written here, should have actually written triangle. And here I should have written trigono. So let's make all of this a little smaller because it's not going to fit. Okay, and then let's move on to the last one. As you can see, it has one obtuse angle, so it's going to be an obtuse triangle, or in Greek, ampligonio trigono. There you go. That's all of them. Now we want to define these three triangles based on their sides instead of their angles. So let's get started. If you took your ruler and you measured each side here, what you would have seen is that all three sides are equal, which would make this an equilateral triangle. Or in Greek, isopleuro. Then, if you were to take your ruler and measure the sides on this triangle, you would find that this side and this side are equal, but this side, the bottom side, is different. So that means this is an isosceles triangle, or in Greek, isosceles. Now, here we finally have a triangle in which no sides are equal, so that would be in English, sorry, scalene, or in Greek, scalino. Here we want to make the heights of the triangle, so that would be, I'm going to do this with my eye instead of a ruler, although I should be using a ruler. But as you can see, I am making lines that are perpendicular to the sides that are opposite of the points that I'm starting from, that are not touching the points that I'm starting from. So I went from A to this side because this side is not touching A. I went from, well, C, let's call it, to this side because this side is not touching C. And these sides, as you can see here, are perpendicular. And then finally, I'm going to go here. There we go. Those are the three heights. That's approximately what your heights should have looked like. So just take this as a general guide. Like if your heights looked about like this, you're fine. If your if your height from here went to here, something, or if your height went from here to here, something. That's where you should reconsider. And I'll see them myself as well on once you upload them. Okay, so again here I'm going to I should use a ruler, but with experience comes the ability to make perfect perpendicular lines. And again, we are not looking to be 100% exact here, just getting a basic understanding of these things. So these are all the distances from the points to the lines. I want to avoid using the ruler because I know that we are already almost at 40 minutes, and I know that at this point you are pretty tired and you are already considering just closing the video. So I would like to avoid that, and that's why I'm just doing this um, just by sight. So you can see here all the distances from point to line. Again, just try to get this as close as possible. If, for example, here instead of making this line, you made this line, or you made, let's say, this line, that's what I want you to reconsider. Okay. Now, here we want to figure out where we can see right angles. So, well, if we can see any right angles, uh, that is. So here I can see right angles, here I can see right angles, and here I can see right angles. Now I'm going to color those right angles, and I'm going to take another shade, another color, because you wouldn't be able to recognize it. Purple and purple. So I see one right angle here, one here. Okay. Because the computer is not cooperating today, I am going to be making them like squares. So one here, one here, one here, one here, one here. Again, these are all the right angles in this shape. Here, here, and there we go. Those are all the right angles on the shape. Now here I can't make them exactly because this one is turned to the side. So instead what I'm going to do is I'm going to just make a big dot. So here and here. Those are the two right angles in this shape. These two don't have any. Circle in here has no angles at all, and then here these triangles have no right angles. Here we have one here and one here. But, yep, there we go. So that's all. That's this exercise done. There you go. If you need to check it, pause the video. And last worksheet. Here we want to make the heights in the first exercise. So let's do that. We have one here and one here. And one here. One here. One here. Come on. And one. Right there. Okay, so there you have all the heights of triangles. Next up, we want to define the following triangles based on angles and on sides. So let's get to that immediately. You can see that this one is isosceles. It has two sides equal. So I'm going to say for its angles, we can see that they are all acute. So we're going to call this acute. And oxygonal. Whereas for its sides, we said for its isosceles, its two sides are equal. Isosceles in Greek. This one is a right triangle because it has a right angle right here. And apart from that, it has no equal sides, so we're going to call it right. We're going to call it right triangle. Trigonal. And apart from that, no equal sides, so scalene. Scalino. Then we have this one here, where if you measure the sides, you'll see that these two up here are equal. So, and it has one obtuse angle, so it's going to be obtuse. And in Greek, ampligonio. And also isosceles. Here, I can see one right angle right there. So it's going to be a right triangle, and then no sides seem to be equal as far as I can tell. So it's going to be the same as this one. It's going to be scalene. Right and scalene. I think no sides are equal. Yeah, they don't seem to. This side seems to be longer than this side. Here we have all three sides being equal and all angles being acute. So we're going to take this actually. No, actually, let's just write it from the beginning. As for its angles, it's going to be acute, oxygonial, and as for its angles, it's going to be equilateral. Or in Greek, sobiolo. Lastly, we have here a triangle with no equal sides and apparently no equal angles. So it's going to be acute and scalene. Do we have anything like that around? No. Acute. Oxygonial. And scalene. Scalino. And that's all. That's all for today. I will see you guys again tomorrow. Oh, sorry, in the next video. So have a good day.